Hello guys, in this video we are going to talk about gradient field and directional derivative. Okay, so we actually already had a chance to figure out how to find partial derivatives. And in terms of gradient, it's really the same thing. It's just a new package, but it's the same contents, okay? So when you are talking about gradient and the letter is like an upside down triangle called del, so this would be del f. What it is, it's basically a vector of partial derivatives. So you are combining the partials into a vector. That's all there is to it, okay? And in this particular case, we need to first find the partial derivative with respect to x, and we are going to be using the quotient rule, which I hope you understand why, because we got an expression that has x both on the top and on the bottom, and that's when we need to use quotient rule. All right, so for quotient rule is if we're doing this with respect to x, so what do we do? So let's go ahead and do that. So for quotient rule, we are going to square the bottom. So remember that the bottom gets squared. And then in terms of the top, first we take the derivative of the top with respect to x. And so when we do that, we disregard any terms that do not have x in them. So if you're looking at x squared, that has x, but the 9y squared doesn't, and so that's actually going to be 0, because when you're taking the derivative with respect to x, you think of y as a number. So derivative of the top with respect to x will just be 2x. And then you multiply that by the bottom with no change. Okay, subtract. Now we want to take derivative of the bottom with respect to x. And again, we only care about the terms that have x in them, which is 5x, and y doesn't. So that's going to become 0 when you take the derivative. And so 5x derivative is 5, right? And you multiply that by the top without change. Now, careful here in terms of not canceling. It's a very common mistake is to look and say, oh, looky, there is 5x plus y right there, so I can cancel it with one of the 5x plus y. But that doesn't work because you also have this other term, and you can't just cancel one but not the other. So that's not going to be good. So you can't do that. Don't touch that bottom. So the bottom is actually going to stay 5x plus y squared, okay? So we're going to keep that. But the canceling or simplifications are all going to be on the top. So you are supposed to distribute here and simplify if possible. So this is going to become 10x squared plus 2xy. Then now we're distributing again over here, over here. So this becomes minus 5x squared. But then the two negatives make it a plus 45y squared. And now we want to see, is there any common term that, or like terms that we can actually combine? So from what I can see, and by the way, never touch that bottom. It's already factored, and you do not want to do any foiling or nothing like that. God forbid you're going to start distributing the square to each part, which completely doesn't work. Leave it be. What I can tell is that I do see like terms. So I see 10x squared minus 5x squared, and that actually simplifies to positive 5x squared. Then we got plus 2xy and plus 45y squared. Okay, so let's check that answer and see if we got that correct. Okay, so 5x squared plus 2xy plus 45y squared. On the bottom, we've got 5x plus y squared. Okay, so let's check that out. Okay, so that is correct. Now we're going to do exact same thing, but now we're going to take the derivative with respect to y. So again, we are writing down our fraction. So it's going to be x squared minus 9y squared. And we divide that by 5x plus y. And now we're taking the derivative with respect to y. So again, quotient rule, the same story. We've got that bottom squared. Now let's see what happens on the top. So on the top, we see that x squared does not have a y, so we are not going to include that. And this guy has a y and also a minus. So be careful with that minus. You want to keep that. So that becomes negative 18y, right? Because derivative of y squared is 2y. Now you're multiplying that parentheses bottom. Very important to put stuff in parentheses because that negative 18y has to be distributed to both terms. Then minus, now derivative of the bottom. Here again, we only care about the terms that have y in them, which is just this y, and 5x will drop out. Derivative of y is 1 with respect to y. And then we multiply that by the top with no change. Okay, so if we were to distribute, and cancel again, please do not try to cancel that 5x plus y with the bottom because it only has that on the first term. All right, so let's just distribute here. Okay, so what is 18 times 5? So I think that would be 90 if I'm not mistaken, because that would be like 50 plus 40. Yeah, I think it's 90. And so we got negative 90xy minus 18y squared. Then this minus 1 is just minus, basically. We'll distribute that minus to both of these terms. So we're going to get x squared and then plus 9y squared. So again, we are looking for terms that can be combined. So I can see that I have negative 18y squared plus 9y squared. So that is actually going to simplify to negative 9y squared, right? So let's see if we can just put that in there. So on the bottom, again, 5x plus y squared. On the top, we got negative 90xy, and then we said negative 9y squared minus x squared. So let's try that.